Hello, grade 12s. We are still continuing with our assignment here. We are now looking at question 3, Euclidean geometry. Now we have got interesting stuff here. This is a very interesting stuff. Euclidean, read the information. Please read the information. Two circles with center at A and B. So we have got two circles with center at A and B. So they are saying here A is the center of this big circle. A is the center of this big circle. And they are also saying B is a center of this smaller circle. And now, let me tell you guys, in Euclidean geometry, when we are describing a circle, we describe it in terms of its center. So I can say circle of center F. It means I'm saying go and look at the circle which has got the center F. So here I've got two circles. I can say circle with center A. So you know that I'm talking about a larger circle. Or I can say circle with center B. You know that I'm talking about the smaller circle. Guys, your diagrams are not drawn to scale. If you look at A carefully, it does not appear to be the center of a larger circle. But we don't, in Euclidean geometry, we don't work with sight. Don't say the way I see it by looking. In this topic, we use reasoning, proofs, and theorems. So it's not about sight, because we will say to you the diagrams are not drawn to scale. So, okay, back to the question. We have got two circles with center A and B. They intersect at X and Y. They are simply saying those two circles meet, they touch each other at X and Y. The radius of a larger circle with center A, it's R. So they are saying we can think of the distance from A to C. Remember, the distance from A to C is the radius of this circle with center A. So you can think of this AC as R. Even AY, you can think of it as R. Even the distance from A to Y, it's a radius. Remember, when we talk about a radius, we talk about the distance from the center of a circle to the circumference. The distance from the center of a circle to the circumference of a circle is a radius. So AC and AY are the radius of this large circle. So they are saying we can represent those radius with capital letter R. And with center A is R, and the radius of a smaller circle with center B is denoted by the small letter R. So we can say the distance from B to D, we can think of it as small letter R because it's the radius of a small circle. Even the distance from B to C, we can think of it, we can denote it with small letter R because it's a radius of a small circle, the distance from B to, we call them equality. Actually, the distance from B to X is equals to the distance from B to D, equality. So let me just highlight on the idea of equality, because this one is very, very important for exam. Remember, B is the center. So the distance from B to D, what is it? It's a radius. The distance from the center to the circumference is a radius. Another radius, it's here. This is a radius. Another radius, it's here. This is a radius. And all radius are equal. So BD, BX, BY, they are equal. Okay? And another thing that you have to take into account, guys, remember, I'm trying to prepare you towards your exam as well. I don't just want you to take them answers here and go. You need to have mathematical understanding. Another thing that I want us to look carefully, we know that since, remember, we said B is the center. So we are saying the distance from B to D is equals to the distance from B to A. This makes the triangle ABD an isosceles triangle. So the triangle sorry, did I say A? It's X here. So this makes the triangle XBD, this triangle, let me just show it with a red color. Yes. So this triangle XBD is an isosceles triangle. Why do we say it's an isosceles triangle? Remember, isosceles triangle has got two sides that are equal. It is isosceles because the side BX is equals to the side BD. And why am I saying the side BX is equals to the side BD? We talked about it, equality. So the triangle XBD is isosceles. And in an isosceles triangle, we also have angles that are equal. It's very, very, very important to identify angles that are equal in the isosceles triangle. So let's observe carefully this isosceles triangle and see which angles are equal. Okay, we know that the side BX is equals to the side BD. So I will call the first side of this triangle the triangle which stand alone, which is not equivalent to those guys. The side which is not equivalent to BX and BT. Remember, BX and BD are equal. So this side, I will call it the base side, which means that the angles seated on this side, which I'm saying is the base side, are equal. So my angle X3 and my angle T2, they are equal. X3 equals to D2. Those are the equal angles. And when you give the reason in your exam, don't talk about the base angles. Just say opposite. These are the angles opposite equal side. Angles that are opposite to equal side are also equal. So you say the angle X3 is equal to the angle D2. Now, if you go still on this idea of isosceles and equal angles, let's go to the triangle ACY. Do you know, guys, that AC is equals to AY? Okay, therefore, I'm going to see the side XY as a base side, and I'm going to say these angles, which is the angle which are opposite to this side, C1 plus C2, and the angle Y4. These angles are equal. So C1 plus C2 is equals to Y4. What is the reason? Angles opposite equal side. Angle opposite equal sides are also equal. So if we have got two sides that are equal, let me just show for the last time here. If I have E, F, G, if I have EF, which is equals to EG, the angles which are opposite to this side are equal because those sides are equal. EG is equals to EF, so the angle which are opposite to those two sides that are equal are also equal, which means that the angle F and the angle G are equal. So just watch out for some isosceles triangle and identify those sides that are equal and those angles are equal. For now, I'm interpreting the information of Euclidean geometry. I've not yet read any question. We are just going through the diagram and trying to obtain an understanding. Okay. Now, let's continue with the reading of information. Let me cancel everything. Now they are saying, okay, CX, the line CX, this line CX, they are saying is tangent to the circle B. So CX is tangent to this circle. CX is tangent to this circle. Okay? Guys, once they give you a tangent, watch out for some tan-cot theorem. You have to remember, you have to know your theorems very well in this case. Once they give you a tangent line, look for the theorem which says the angle between the tangent and the chord is equals to the angle in the other segment. So let's observe the angle between the tangent and the chord. Let us look for that angle, which is between tangent and the chord. And we know geometrically that the angle between tangent and the chord is equals to the angle in the other segment. Okay, let me look for that angle which is between the tangent and the chord. So I'm saying CX is tangent, which means that XY is my chord. This is my chord. Remember, a chord, it's a line segment from one end of the circumference to another end of a circumference. So there is X here. So the line XY, it's a chord. And a chord divides your circle into two equal parts. Sorry. Did I say the chord divide the circle into two equal parts? Sorry. The chord divide the circle into two parts, into two segments. So we're going to have this segment, the smaller segment. Maybe I can color that segment with a blue. The smaller segment of a circle, just because XY, it's a chord. And the other segment is this one. This is a bigger segment. So your circle is divided into two segments. The chord divides the circle into two segments. And now if you check carefully, the angle between the tangent and the chord is in this segment. So the angle between tangent and the chord is going to be equal to the angle in that red segment. So let me erase everything so that we can be able to observe our information. So we said this line is tangent. This line is a chord. So we are having the angle x1. We are having the angle x1, which is between the tangent and the chord. And we know that the angle between the tangent and the chord is equal to the angle in the other segment. So I will have to come to this side of a circle and ask myself, which angle is equivalent to x1? You know what you do? To find that angle which is equal to x1, observe the chord carefully. Remember, I said x1 is between the tangent and the chord. Which chord? XY. You use that chord XY to find the angle which is equivalent to x1. How so? Let's observe. Let's go. We look at my chord X. Look at my chord Y and say, this Y here it's X here. Can I move from X and move from Y with two lines and meet at the circumference? Yes. If we move from X on this line and move from Y on this line, we are going to meet at D, which means that X1 is equals to D1 according to the tan-cot theorem. So once they give you tangent, watch out for tan-cot theorem. Just look for the theorems of tangent, not only tan-cot. Once they give you tangent, look for the theorems that has to do with tangent. So in this case, we observed x1 equals to d1 according to the tan-cot. Another thing that we can observe I'm teaching, I'm not giving away answers actually here. Another thing that we can observe, this tangent, the line XP is a radius. So we have this radius, which means that the angle X1, let me check carefully. Yes, the angle X1 plus X2 plus X3 is 90 degrees because tangent is perpendicular to the radius. Yeah, I observed that this theorem actually was not useful when we were answering this question 3, but it's part of theorems in Euclidean geometry. Tangent is perpendicular to radius, so they form 90 degrees. They said CX is tangent. They said XR is a radius. So these two angles forms, did I say two angles? The angle between the tangent and the radius will form 90 degrees. Guys, I've been talking, creating a video, creating another one. So just bear with me. Just bear with me if you find some errors, but I will try to be accurate. By all means, I will try to be accurate. So now, okay, we have talked a lot. We have talked a lot. Okay, another thing that they told us is that dx is tangent to the bigger circle. Dx is tangent to the bigger circle. So dx is tangent to the bigger circle. So on the big circle, let me have this as my chord. Let me have xy as my chord. Yes, this is a chord of this big circle. So which means the angle x2, which is the angle between the tangent and the chord, is equals to the angle in the other segment. X2 ye yo lekana leng, yo lekana le C2. X2 yo lekana le C2 according to the tan chord theorem. How did I know that it's C2? Just use the same chord. Use the chord CY. Draw a line from C. Draw a line from Y. Go to the circumference. Don't stop anywhere, but only at the circumference. So you see that actually C2, X2 equals to C2 according to the tan chord theorem. Okay, so I think we talked about every theorem which is important on this problem. Now we can go and start answering questions, which is what you guys want. You want to see the answers. Let me give you the answers. Okay, so now 3.1, this is a tricky question. This is it's bit of a tricky question, but since you guys, you will be exposed to these questions, it won't be tricky anymore. Because they are saying prove that xy squared is equals to dy times yc. Okay, this kind of problems, guys, they appear from the similar triangles. Sometimes we have to prove. I love this 3.1. They did not ask us to prove that the triangles are similar. They just say prove that xy squared equals to dy times yc. But to solve this kind of problem, sometimes it will be very important to first prove that we have triangles that are similar and take it from there. Take it from similar triangles. When we give you something like this, guys, please, when we say prove that AB over BC is equals to Q over QR. I'm just bringing my stuff here. This might be coming from similar triangle. That this might be as a result of similar triangles. So even though they did not ask you to prove that triangles are similar, you will need to first, sometimes it's very important to first prove that triangles are similar. Then once you see that triangles are similar, it will be easy to prove whatever they want, like xy squared dy times yc. So I'm going to say, let's do this, let's come to the diagram on the question and say, this guy is talking about xy. Where is xy? This is xy. He talked about dy. Where is dy? This is dy. He talked about yc. Where is yc? This is yc. And I'm thinking, maybe this guy wants me to show that this triangle here, it's similar to this triangle here. Say maybe if we prove that the two triangles are similar, then we will be able to prove that xy squared equals to dy times yc. So watch out for some similarity of triangles. So let's check. If we want to prove that two triangles are similar, we are going to work with angles. So for example here, if you look at the angle x2 on this triangle XYT, the triangle represented with a red color, you will notice that it's equals to C2. According to the tan chord theorem, actually I said it, X2 equals to C2. Okay, or you can say C2 equals to X2, or you can say X2 equals to C2. So you say tan chord. Make sure that you see that is tan chord. So one of the angle in the red triangle is equals to the angle in a blue triangle. So you just have to check for angles that are equal when you are proving for similarity of triangles. So what else do I do? Which other angles can be equal from these two triangles? Let me check. X1 equals to D1. X1 equals to D1 according to the tan chord theorem. Make sure that you check this tan chord theorem. X1 equals to D1. I explained it. Please make sure that you check it. So I will say X1 equals to D1. Now, what is this one? Is still tan chord. Once I have got two angles that are equal, one angle from the triangle is equal to another angle from the other triangle, and the second angle from the blue triangle is equals to another angle in the red triangle. Once I have two, the third one, I don't prove it. I just say third angles of a triangle. So I'm going to look at the angle, this angle y3 plus y4, and say equals to y1 plus y2. This is the third angle of a triangle. Or you can call it xyc and say is equals to xyd. Reason is the third angles of triangles. So, which means we have proven that the triangles are similar. You have to make sure that you write them in the correct order. So here, because C is equals to X, when I write C this side, I write X this side. Because X equals to D, when I write X this side, I write D this side. Because Y equals to Y, yes, so I will do this. And say the triangle, I must say triangle CXY, it's similar to triangle CTY. So I have proven that these two triangles are similar. And maybe from this similarity of triangles, I can show that XY squared equals to DY times YC. Let's see, let's check. Okay. Now, because we have proven that the triangles are similar, we have a right to apply the theorem that says corresponding sides of similar triangles are in proportion. So here I will say CX, I picked the first two, I will pick the first two here, XD equals to, I'm picking the last two, which is XY. So XY over, let me pick the last two, DY equals to, let me pick the last, the first and the last, CY over XY. This is the corresponding sides of similar triangles. Corresponding sides of similar triangles are in proportion. So now here I'm just going to pick two guys, which I believe might help me in solving the problem. I need this XY and DY, because here we do have XY and DY. And I also need this CY and XY, because here we do have CY. So I will just focus on these two. I will just say XY over TY equals to CY over XY. Sorry. And then if you do cross multiply, XY squared, XY times XY is going to be equals to DY times YC from cross multiplication. It's very late and I don't have a light where I am. Let me just stop my video. I mean, my battery is running low. I will have a serious problem. Very, very, very big serious problem. I can't afford to have this work disappear after such. Oh my God. What's happening? Bear with me, guys. I'm sorry. Imagine if all the work just disappear after such a hard work. Please say you are charging. Yes. Yes. Okay. So after cross multiply, we see that xy squared equals to dy times yc. I'm happy because my work is safe. It was going to be something else starting over. So 3.1 solved. Let's go to 3.2. Okay. On 3.2, they are saying prove that A1 equals to B1. A1, this is the angle. Yeah, ne? There is a problem with this charger. It does. Now it's charging. Okay. So the same proof that A1 equals to B1. My charger has a serious, very serious problem. Because I'm not even, I have to do this one, guys. This one, uh, this is so bad. What? I'm hoping it. Okay. 3.2, A1 equals to B1. I did not talk about the angle at the center. They told us that A is the center. Once they mention the center, you also have to look out for the angle at the center. So A1 is the angle at the center. And what subtend this angle A1? If we look at these two lines that form the angle A1, where does these two lines comes from at the circumference? One comes from C, one comes from Y. So we say the angle A1 is subtended by CY. It's very important to know what subtend the angle. So the angle A1, which is the angle at the center, it is subtended by the chord CY. So I'm going to look for the angle at the circumference, which is subtended by the same chord CY. And if you observe carefully, this angle X1, if you observe where this line comes from at the circumference, it comes from C. Where does this line comes from at the circumference? It comes from Y. So the angle A1 and the angle X1, they are both subtended by the same chord CY. So that is why I will say A1, it is twice X1, angle at center is twice the one at the circumference. You will write the theorem, guys. A1 equals to 2x1. You write the theorem. Normally, when I write the theorem, I write it in full. I don't do shortcuts. Okay, so A1 equals to 2x1. That is what I see about the angle A1, which is the angle at the center. So I want to prove, remember, I want to prove that A1 is equals to B1. What I know about A1 is that it's equals to, it is twice X1. So what about the angle B1? Yeah, this one can be very tricky. Make sure that you understand here. The angle B1 also is the angle at the center. What substance the angle B1? It's X, Y. So we're going to look for the angle at the circumference subtended by XY. So we notice that it is the angle D1. This angle D1 here. It is also subtended by X, Y. So we say, okay, B1, it is twice D1, angle at the center, it is twice the one at the circumference. Yes. So B1, it is twice D1. Okay, so A1 is twice X1, B1, it is twice D1. Okay, and I want A1 and B1 to be equal because they are saying I must prove that A1 equals to B1. But what do I know? I know that A1, it is twice X1. What else do I know? I know that B1, it is twice D1. So this time around, guys, we wish that X1 and D1 are equal. Because if X1 and D1 can be equal, it means A1 and B1 will be equal. Imagine X1 being 30. How much is going to be A1? Is going to be 2 times 30, which is 60. And imagine D1 being 30. What is going to be B1? Is going to be 2 times D1, which is 60. So for A1 and B1 to be equal, the X1 and the T1 need to be equal. So let's check, is X1 and T1 equal? Yes. X1 and T1 are equal based on a turn-chord theorem, which I've also explained. I've explained the turn-chord theorem. I said the turn-chord theorem is the angle between the tangent and the chord. We look at the angle between the tangent and the chord, which is X1. And then we know that the angle between the tangent and the chord is equal to the angle in the other segment. To find that angle, I said use the chord XY. Use XY. So you move from X, you move from Y, X is here, Y it's here. You move from X, you move from y, you meet at D1. So x1 equals to D1. Okay, so it means you can go to A1, you can say A1, it is twice D1. If you want, you can substitute x1 with D1 because x1 and D1 are equal. And we know that B1 also, it is twice D1. Therefore, A1 and B1 are equal. So now let's go. Let us prove similarity of triangles. So we are going to the third problem. We want to show that triangle CAY, it is similar to triangle YBX. Let me be honest. When I was solving this one, it took me a lot of time. I missed something and I was like, what's happening? I looked and looked, could not get to the answer. I missed something which everyone knows. We all, you will see how I solve this problem. You will see that what I've missed, everyone knows actually. We all know it, but it's easy to miss it in the exam. I will show you what I'm talking about. So we want to prove that the triangle CAY, it's similar to the triangle YBX. Okay, proving similarity of triangle, it's easy. Focus on angles. So I will say to you, check if angle C is equals to angle Y. So we're going to check if angle C is equals to angle Y. So let's check. What do we know about angle C? Remember, C in the triangle CAY is C1 plus C2. So we want to check if C1 plus C2 is equals to, I want this C1 plus C2 to be equals to angle Y in triangle YBX, which is Y2. I want these guys to be equal because I know what triangles will be similar if they have got angles that are equal. It's very important actually to highlight the triangles they are talking about. It is C. We're looking at this triangle. And we are looking at which other triangle? These are the triangles that we are proving that they are similar. YBX. So from these two triangles, we want to check which angles are equal. So just because they started with C here, the angle C must be equal to the angle Y. So I'm going to say the C1 plus C2 somehow must be equal to Y2. And A, which is A1, must be equals to A will go with B. A must be equals to B1. B1, I'm referring to this one. And this one, we already proven that A1 equals to B1. So if I'm proving that these two triangles are similar, right away I can say A1 equals to B1 is proven. So that was my first. So I just need the second angles that are equal, then I'm done. The third one, I will say third angles of a triangle. Let me just write it. But I will still need to check which angles I'm working in. So I need the second one, I'm done. And which means I want C1 plus C2 to be equals to Y2. Or maybe I want Y4. Maybe I want Y4, 1, 2, 3, to be equals to X2 plus X3. I'm going to put my focus on C1 plus C2, which I say I want it to be equals to Y2. So I have to check carefully what is it that I know. Okay, I know that C1 plus C2 is equals to Y4. How I'm solving the problem is very important. Remember, I want C1 plus C2 to be equals to the angle Y2. I'm proving the equality of these two angles. So I have to put my focus on C1 and C2, also on Y2. So what do I know about C1 and C2? I know that C1 plus C2 equals to Y4. So since C1 plus C2 equals to Y4, if Y2 also can be equals to Y4, if, let me write this statement down, if Y2 is equals to Y4, then C1 plus C2 will be equals to Y2. And this is what I want. I want C1 plus C2 to be equals to Y2. For now, I know that C1 plus C2 equals to Y4 because the side AC is equals to the side AY. So the angles which are opposite to this side are equal. So C1 plus C2 equals to Y4. And I want C1 plus C2 to be actually to be equals to Y2. But I see that C1 plus C2 equals to Y4. Now, if I can show that Y4 and Y2 are equal, then C1 plus C2 will be equals to Y2. So let me try to check if Y2 and Y4 are equal. And this is what took me a lot of time, trying to show that Y2 and Y4 are equal. This is where the trick is. And watch out. Watch out. It's not everyone think like this in the exam. I'm not surprised why it took me time. You can say Y2 plus, I'm focusing on the triangle BXY. So I'm going to talk about the sum of angles in a triangle. So I'm taking this Y2 here. I'm adding it with this angle here, which is x2 plus x3. And remember, x2 plus x3 is also equals to y2 because this side and this side are equal. So bx and by are equal. So we have an isosceles triangle bxy, making these two angles here, y2 and x2 plus x3 to be equal. So I will say, okay, let me raise so that you can see. I will say the angle, my focus is on the triangle BXY. My focus on this. So I know what y2 equals to x2 plus x3 because this side equals to this side. So these angles, the opposite to equal side, so they're equal. So I'm going to say y2. This x2 plus x3, I will just call it y2 as well because x2 plus x3 equals to y2. And say plus b1 and say equals to 180. This is the sum of angles in a triangle. So 2y2 is equals to 180 minus b1. Therefore, y2, if I divide both sides by 2, it's 90 minus b1 over 2, which is half of b1. So this is my y2. And this y2, I really want it to be equals to y4. So let me go and check about y4. What do I know about y4? This was a bit tricky. Now we are focusing on this triangle A, C, Y. So I'm going to say, allow me, or let me just write here. I'm going to say y4 plus, this is y4. This C1 plus C2, I know that is equals to y4. So I will say plus y4. Those are the opposite angles of equal side. Plus A1 equals to 180. Therefore, I have 2y4 equals to 180 minus A1. Therefore, y4 equals to 90 minus half of A1. So y4 equals to 90 minus half of a1, y2 equals to 90 minus half of b1, and we know that this b1 and a1 are equal. So therefore, automatically, y2 and y4 becomes equal, because it is the same as, let's say on y2, I can say this is y2 is equals to 90 minus half of b1. And when I come to y4, I can say y4 equals to 90 minus half of, I can substitute a1 with b1, because we know that a1 equals to b1 from 3.2, it was proven. Therefore, y2 is equals to y4. Now, because y2 equals to y4, it means that y2 also is equals to C1 plus C2. C1 plus C2 is equals to y2. Why? We know that C1 plus C2 equals to y4. And y4 is also equals to y2. Therefore, C1 plus C2 also equals to y2. So now I've proven that this angle equals to this angle, A1 equals to B1. Therefore, I can say, let me raise and see which angle I've proven. I've proven that A1 equals to B1, it was given, and I just showed that Y2 is equals to C1 plus C2, which means that Y4 is equals to X2 plus X3. So Y4 is equals to X2 plus X3. What this is third angles of triangle. Therefore, the triangle CAY is similar to the triangle YBX. Guys, you will need to practice. I won't be surprised if you get these things right away. You need to put effort. So try to go again and again and try to understand what I'm talking about. Okay, so let me go to the last question in this problem. The last question in this problem, it says that prove that r squared, small letter r squared over high font R, which is capital letter R squared, equals to dy over cy. Okay, immediately when there is no proof our triangles are similar, we can do this. Remember, we said K, it's similar to CAY is similar to YBX. So you can say CA over YB equals to AY over BX equals to, I took C and Y over Y and X. Now compare this. The reason is corresponding sides of similar triangles. Remember, we have proven that triangles are similar. So you have to compare this to where you want to go. You want to come to this one. So let's check. We want dy cy. I don't see dy and cy. Oh, cy is here. Cy, I have it. Maybe I will use this one. And what else? Okay, I need to pick two. So CA, I know I have to pick it. Let me go back to the diagram a bit. Yes. CA, I have to pick it. Why do I have to pick CA? CA needs to be involved because this is a radius. This is a capital letter R. They said the radius of this big circle is represented by the big letter R. So this part I have to take it. I have to take CA over YB. What else do I have to pick? CA. Oh, but I have to be careful because even AY, it's also it's possible maybe to also pick this one because CA and AY, CA it's R, even AY, oh, CA is capital letter R, even AY is capital letter R because the distance from A to Y is still the radius. So these two guys are my radius. CA it's my capital letter R, AY also, the distance from A to Y, it's also my R. So I'm still confused which one to pick because both of them, they can give me capital letter R. Okay, so let me go to the small circle. From the small circle, what is my radius? It's BX. I don't have BD. Yeah, obviously I have this B. Oh, yeah, distance from B to X. Let me do this. I need this. Yes, the distance from B to X, this distance from B to X is my small letter R, is the radius of the smaller circle. So I need this BX because it will give me the radius of a small letter circle. So let me say, okay, let me pick, okay, can I pick them both? Can I pick them both? I know, so CA over YB, YX, I don't think YX, I don't need it. But TY, I need it. CY, I need it. Maybe I have to pick CY, but I don't need CX. So, I need to, I know I have to pick two from this three. So I'm deciding which one to pick. YB, YB. Oh, YB, it's AY. YB is I think CA over YB, I know I have to pick it. So CA over YB, I'm going with it. CA over YB, because I know that CA, this CA, is capital letter R, YB is small letter r, is the radius of a smaller circle. YB also is the radius of a small circle because B is the center. So CA over YB equals to, so I have R over Y, and then maybe I might, now I see what's happening. So now I need DY over CY. Okay, I need CY. Let me just involve CY, but I need CY. So maybe I say CY over YX. How am I going to substitute YX? Because I don't need it. This YX, I don't need it. I've never used tangent is perpendicular to the radius. And then they are not even on the same. I don't have the triangle. This is going to be a bit tricky. This is going to be a bit tricky. So which one do I go for? AY over BX or CY over YX? AY over BX or CY over YX? CY over YX or CY over YX? I doubt. CY over YX, I doubt. Maybe I should pick AY over BX. Maybe I should pick AY over bx. And then how am I going to express bx? Ay over bx. And I have to take into account I'm using it, the information of above. So it's ay over, I'm thinking we have to go with ay over bx. And ay represent what? Capital letter R over bx. So currently I'm having something like this. I'm having R over small r equals to R over bx. And bx should not be there on the problem actually. Bx should not be there on the problem. Something is not adding up, guys. Something is not adding up. So I will have to erase everything and think carefully about this. I think I've been working with this problem, so my mind might be a bit tired. So, but I know we have to focus on 3.3. This one need to help us. So you say CA over YB equals to AY over BX equals to CY over YX. CA, this guy might be very useful. YB might be very useful. CAYB, I'm tempted to pick this guy. And then AY BX. Yes, I'm tempted to pick these two now. These two. So CA, remember, is capital letter R. R over YB. YB is small letter r equals to AY is capital letter R over BX, which is small letter r. Okay, which is true. Which is true. Capital letter R over R is equals to capital letter R over R. This is true, but it's not helping us to solve the problem. This is true, but it's not helping us to solve the problem. So what am I missing? Maybe I should involve CY over YX. CY over YX. What do I know about CY over YX? We've talked on 3.1, we talked about XY actual. We've talked about this XY and then CY. Maybe we need to involve the problem of 3.1. I won't be confused why it's beating me up if it wanted me to involve. So let me take CA over YB and CY over YX. CA, which is capital letter R, over YB, which is R, equals to CY over YX. What is YX? Okay, CY over YX. Okay, CY over YX. Let me make CY over YX the subject of the formula here. And I will have dy. How can dy be useful? Not even, I don't see dy being useful. I don't see dy being useful. This is mathematics for you guys. It happens. It happens. But it's just formal. I mean, this should not be difficult. I'm being honest. This should not be difficult. So I wonder what's happening. CA over YB equals to AY over BX equals to CY over yx. And I believe in my first step. My first step should be right. So CA, which is capital letter R, YB, which is small letter r. So capital letter R, that's why this one I need it. Capital letter R over small letter r, I need it. And for me to have this r squared and r squared, they need to come and multiply each other. I need to have something like maybe r on top and r underneath. So that's this one and this one will multiply each other. So that r times r will give me r squared, r times r will give me another r squared. Remember, another one is capital, another one is of a small font. So do I survive? Yes. CA over YB equals to AY over BX equals to CY over YX. CY over YX. I don't have parallel lines. And I've proven too many triangles that are similar. There are some triangles which have proven that on 3.3, and I've started with another triangle. I once proven that it's similar as well. Oh, when I was solving 3.1. So xy squared x y dy cy. Oh, this dy cy might be coming from some triangle which are similar. Okay, I think here on 3.1, I had something like xy. Now I'm being desperate here. yc equals to xy dy over xy. I once said something like this. So xy squared equals to dy times yc. dy times yc. Okay, guys, if I find the problem for 3.4, I'll just come and post it because I think my mind is tired. I've been working with throughout during the day, so I don't see 3.4, but I don't think it should be difficult, to be honest. There's just something which is there's something which I'm not taking into account here. There's something which I'm just not taking into account. Dy over cy. Well, how do I get this dy over cy? Oh, dy over cy might be coming from these two triangles. Let me erase and see here. If I say dy cy, just these two guys. There is this guy dy. There is this guy cy. One come from this triangle. The other come from this triangle. Okay. Is this triangle even similar? Or I see. Or I look at this triangle, maybe. I look at this triangle. At first, we have proven that this triangle, it's similar to this triangle, but problem we don't have, on this triangle, we don't have dy now. On these two triangles, we don't have dy. I will look at it, guys, and see. Once I get it, I will post it.